Okay, so the purpose of this video is going to be to go over sketching graphs. We started this on Friday, but this is going to be a little bit more in depth. The first thing that I do is take a look at the characteristics that are given to me, and the first line you can tell are just coordinates. -1, f of -3 equals f of 1, which equals 0. So that means this is the point -3, 0, and this is the point 1, 0. And what I do is I just go ahead and plot those: -3, 0, 1, 0, and then I also have -1, 2. So that's going to be up here. The next thing I notice is it tells me that the derivative at -3 and at -1 both equal 0. So that tells me that at -3 and at -1 I'm going to have some sort of flat horizontal section of the graph. Now, the next piece of information says that the first derivative is negative from -infinity 3 and from -1 to infinity. So when I read first derivative is negative, that tells me that my function must be decreasing, and when the first derivative is positive, the function must be increasing. So I can already tell that from -infinity to -3 I'm going to be decreasing, so it's going to be coming down, and then it's going to turn around because it has to come right back up and then down. Okay, so I can kind of tell that that's what's going to happen. So let me draw that. Okay, now the last piece of information is the second derivative. Second derivative is positive from -infinity to -2, so that would mean concave up, and negative would mean concave down. So I'm just going to check my graph and make sure it matches. So I do have concave up. The concavity should be switching at -2, so maybe I should erase this piece and make it a little bit more clear where that inflection point happens. So the inflection point is going to happen at -2 from concave down to concave up. It's a little hard to draw with this pencil, but I think in general I have the shape of the graph pretty well. So the inflection point is happening at -2, and that's it. This is my graph. I'm going to show you a second example, and I'll go ahead and pause and set that up for you. So with this example, we have the point -4, 1, 3, 0, and 0, -4. I always like to start with those because they're easy to plot. So -4, 1, 3, 0, and 0, -4. Right here. Okay, and the next thing is note that at 0 the derivative will be 0, so that means the point 0, -4 is probably going to have some sort of horizontal part to the curve, maybe a turning point it looks like, but then at -4 the derivative does not exist. So we're gonna since we have a point there, the function exists, so if the derivative doesn't exist, that must be a corner or some kind of cusp. Alright, so now the first derivative positive in these two intervals, and there's a u missing here. That means that the function must be increasing. Negative would mean decreasing, and there's a u missing in this one too. If the second derivative is positive, for basically from -infinity to -4 and from -4 to infinity, that means that we're going to have concave up the whole time, but at -4, which happens to be where the derivative doesn't exist, that's excluded, possibly because that's going to be more than likely it's going to be a corner or a cusp. So I'm going to be increasing to start and I'm going to be concave up. So that means something like, let me try that again. So concave up, that means it's going to be concave up here, so I'm just trying to do increasing concave up. Now it's going to decrease from -4 to 0. So from -4 is just going to decrease. So I'm thinking something like this. And then I'm just going to go ahead and check and see that everything's in order. I have increasing from -4, from negative infinity to -4. And then also from 0 to infinity, which happens here. Then I have decreasing from -4 to 0, so I have a decreasing behavior. I do have my zero derivative at 0 right here, nice turning point. And I also have concave up the whole time. Concave up, and I think this looks weird, but it's supposed to be an arrow. So that's it. Normally I start with my points, and then I just kind of make sure it's increasing, decreasing in the right areas, and then I just double check my concavity. So that's an example of sketching. Go ahead and try your assignment, see how things go.